Hello everyone. In this video we have several topics to cover under OpenCV, and for that we need to import CV2 and NumPy. So the first topic is to change the intensity of the pixels, which basically means change the image brightness. So instead of pixel intensity I can say brightness change. And for that, we can use the built-in commands add and subtract and pass to it the image that here I can read in black and grayscale or in color. And I can add so much to the light intensity of it, or I can reduce so much, so I can basically make the image darker or brighter and show it to you. And this add commands and subtract commands can be also used to add and subtract two images from each other instead of an image and a number. So let me go ahead and first show you, if you add so much or reduce so much from the image, how you can make the image brighter or darker. So here, if we go and see, this is the original image. And then these are the two images on the side. On the left, you see here I have intensified the light intensity so the image looks brighter. And here you clearly see that the image looks darker, right? So this is what this is, add and subtract for a single number. The next thing we have, as I said, the command add can be used to add two images together. And a better version of that is called add weighted. So here you can combine two images together, but gives them different weights. Instead of each one of them half and half, you can use different weights, and that is called image blending. And the weights are alpha and beta, and you can even add a constant of gamma to the result and then call the overall thing the output image. So here I use 0.6 of one image and then 0.4 of the other image and no constant, and I show you the blended image, which is the image Lena plus an OpenCV image in the background, right? So here we go. You see the OpenCV is a dark image. It's all dark here, and then you have these three circles or kind of letter C's, and then the OpenCV, and then I masked image Lena with the OpenCV, and I got this blended image that you can see over here, right? So this is image blending using weighted added. The next thing you can do is image masking. So what you do here is you create a binary image and then you mask your original image with this mask, and that is where you want to show only a portion of the image and mask the rest of the image, right? So what am I doing here? I'm creating a mask which is the same size as the entire image. So you see I'm using image.shape and no beginning all the way to 2. What does that mean? It means shape 0, 1, and 2. So all three numbers basically. So I'm using the size of my image, whatever it is, the number of rows, columns, and channels. I'm using all of those dimensions. And then I'm using the type of variable as uint8. So create a bunch of zeros of type uint8 and an image with the size of my original image, and then go ahead and use the command circle that I showed you in the previous video, and then basically add it to the image mask. Go to the location 220 and 280 with the radius of 90 and all colors white. Go ahead and -1 means fill it with all white. So create a white circle with radius 90 at this location center and add it to my image mask. So now image mask is not going to be all black. It has a white circle in the beginning, in the middle, and then that means it's now mask is a binary mask. So if I do bitwise AND between image and what? The mask to be this mask, and then write it back to the image, right? And then assign this to the variable mask. So what am I doing here? I'm saying that use the image, use the mask, and use a AND between them. So wherever it's what? Wherever it's 1 or 255, you're gonna get what? You're gonna get those pixels in, and wherever it's 0, you're going to get those pixels out, right? So I'm using a bitwise operation between them. And so this is going to only show the image Lena inside the circle, and anywhere outside it, because it's ended with a 0, you're not going to see anything. So look here. You see, this is that circle. That was white. If you want, I can show you that binary image as well, that mask. And then you see that only this portion inside the circle is 1. The rest of it is what? 0. So when you end it, you're not going to see the rest of the image. So this is called masking, right? So let me stop the code. And because it is going to keep going, right? So let me go back here. You might say, well, if I said 1, is that still gonna work, right? If I make them 1, because remember your type is uint8, right? So if you say 1, would that still gonna work? And then also, could you show me the mask image? So the mask itself, not the masked image. And the answer is yes. So here I can show you the mask itself. And the question is, if I make this 1 instead of 255, would that work? So let's go ahead and run this. And here is the result. You see that it does work because you're ending it with 1. So it is definitely working, but look at your mask. Your mask now is not going to show the way that you want it. Why? Because your numbers are only 0 and 1. Okay? So when you show the mask, you can barely see any circle here with numbers 1, right? So that's why I use 255, because here you have a circle, but the numbers are 1, which is barely any different from 0. So you see, for AND operation, it does work, but when you want to visualize that mask, since the numbers are uint8, not double, they are not going to work that nicely. So my recommendation is get it back to 255, and although this is a uint8 image, it is going to work with the bitwise AND operation, so it is going to act like a logical image for you. Okay, this way you can see the results quite a bit better here, right? So that is your circle. This is the image Lena, and so you can change the location, the size, the shape of this, and focus on any part of the image that you want. This is called masking. Good. What else do I have? The next topic is getting the RGB channels out of the image, maybe merging the channels and so on. So as I showed you in the previous video, you can get the first or the second or the third plane of the image by this last number. So if you say 0, that's the blue channel. If you say 1, that's the green. If you say 2, that's the red channel, right? I showed you that the other command that you can use, the split command. So if you say CV2 split of the image, it is going to split it into B, G, and R channels, and then you can show any channel that you want. Another thing you can do is you can combine, let's say, 2 of these channels and show the result, and that is using the command CV2 merge. So what I'm merging here is the green channel and the red channel. I keep them, but instead of the blue channel, I create an image that is all zeros of type uint8, and the size of it is the same size as the image itself. And so I merge them together. So what I'm doing here is basically, instead of the blue channel, I'm putting a bunch of zeros. So I only keep the red and the green channel, and then I show you the result, right? And that could be quite a bit interesting, right? So this is the image. The whiter it is means the closer it is to red, and the darker it is, the further away it is from the red. And here is, if I only keep the red and the green channel, you know, when you combine red and green, you will get basically what? You get yellows and orange colors mostly. So this is completely making sense. If I kept the red and the blue channel, you would get a bunch of purple colors here, right? So you can do manipulations like that if you want, right? Splitting, merging channels together. The last thing I want to show you is Colorspace conversions, which are really useful for many applications. So what I do here is I use the command cv2.cvtcolor. So this is converting colors. and I go and convert my RGB color or BGR color space into what? BGR to HSV. So I convert it to hue, saturation, value, HSV color space. And then I can split that new result into H, S, and V. Then I can show you the hue channel, I can show you the saturation channel, I can show you the value or the light intensity channel, right? Another thing I can do, I can instead use the CV2 color, but the argument I use is CV2 color underscore BGR to gray. This way I convert my color image into grayscale. You know, when you read the image, if you use 0, that is gonna make it color. That is gonna already make it grayscale, right? So I know that from the previous video, so I can convert it already to gray when I read it, or I can read it with color and then use this method to convert it to grayscale and show it. And another color space that is very useful is LA star B star color space, which is the kind of independent from the monitor, from the screen, or anything, the sensing device, right? That is a very specific color space that we use for many computer vision image processing applications. When you want your results to not depend on the capturing device or the displaying device or anything like that, the channels are completely uncorrelated to each other and so on. And L is light intensity, and A's and B's are different between two colors, basically. I'm soon gonna make a video on color spaces, my computer vision and image processing playlist, and I'm gonna publish it soon, so you have the theory behind this. But here I'm going to show you all of these different channels here. So this is hue, saturation, and value. And value is basically, as I said, light intensity. So the wider it is, the brighter it is. Saturation is the richness of the color, whether the color is washed out or very rich. The wider it is, the richer the color, the darker it is, more washed out. And then hue, of course, are different values for different colors, right? So you'll see the HSV color space, basically, how it looks like. And then, of course, we can look at the grayscale, and then we can look at the L, A star, and B star. And again, I'm gonna provide information about them in that video I'm gonna publish, and you'll see that A star and B star are different between two colors mostly. And L is the same as the light, we call it lightness, it's the light intensity. So here you have seen color space conversions. Splitting and merging color channels like RGB, the masking of the image blending, and the brightness change. So hopefully this video is useful to you, and I'll see you in my next video. Thank you.